Group 5 Avogadro, introducing VSEPR theory and molecular geometry.
So we have here the linear molecular geometry. So in chemistry, the linear molecular geometry describes the geometry around the central atom bonded to two other atoms placed at the bond angle of 180 degrees. An example of linear electron pair and molecular geometry is BeH2 or beryllium hydride. So this molecule is electron deficient and does not follow the octet rule because it has only 4 valence electrons. So the hydrogen atoms are as far apart as possible if opposite each other at 180 degrees. So this is the linear geometry.
So trigonal planar is a VSEPR molecule shape. It has 3 bonding groups, 0 lone pair, and 120 bond angles. It is trigonal because it has 3 things surrounding the central atom, 1, 2, and 3. And it is planar because it is arranged in a straight plane. Such can be seen in boron trifluoride, where boron is the central atom and fluorine atoms are surrounding boron atoms.
So this molecular shape right here is called a bend. As you can see, this is quite similar to a trigonal planar discussed a while ago. This is the trigonal planar. The only difference is that this surrounding atom right here is replaced with 1 lone electron pair in the bent shape. So, the same in the trigonal planar, these angles right here are all 120 degrees. And this one, since the lone electron pair pushes the 2 surrounding atoms closer together, instead of having 120 degrees right here, this angle right here is a little less than 120 degrees, approximately 116 degrees. This molecular shape right here is actually called a bend because the 2 surrounding atoms here are pushed closer together, forming a bent shape.
This molecular shape is called tetrahedral, where all of the bonds wanted to push against each other. This is tetrahedral because there are 4 things or 4 bonds in this molecular shape, and there are 109.5 degrees between any of the 2 atoms or bonds that are next to each other. 109.5 here, 109.5 here, and so on. And an example of this molecular shape is the CH4, or also known as methane, where the central atom with having 4 valence electron and there are 4 hydrogens surrounding it, and this is tetrahedral.
So trigonal pyramidal is a molecular shape that results when there are 3 bonds and 1 lone pair on the central atom in the molecule. So example of trigonal pyramidal is the NH3. NH3 also has 4 things around the central atom, but not all of them are bonds to the other atom. So we have 1, 2, 3 bonds and 1 lone electron pair. So this is the trigonal pyramidal looks like in 3-dimensional shape. It is called trigonal pyramidal because when you look at the side, it looks like a pyramid. As you can see, it is almost similar to the tetrahedral shape a while ago. The only thing that they differ is that 1 atom of the tetrahedral that surrounds the central atom has been replaced by the unshared electron, which is this one. This unshared electron has been pushed harder against the 2 bonds, and so that means that the angle between these bonds is pushed a little tighter. That's why it is smaller. From 109 degrees, it becomes 107 degrees. So 4 things around the central atom, but there are only 3 bonding electron and 1 lone pair.
According to VSEPR theory, T-shaped geometry results when 3 bonds and 2 lone pairs of electrons are bonded to the central atom. Examples of T-shaped molecules are the halogen trifluorides such as ClF3 or chlorine trifluoride. Chlorine trifluoride has 10 electrons around the central atom. This means there are 5 electron pairs arranged in a trigonal bipyramidal shape with a 175 degrees FCLF bond angle. There are 2 equatorial lone pairs making the final structure T-shape. These lone pairs are pushing the atoms inward so it will not create a straight line because of the repulsion of those electron pairs. So that means that this line is going to be a little less than 180 degrees. This also means that the angle from the axial to the equatorial will be a little less than 90 degrees.
So this is the 3D structure of the seesaw. So this is a type of molecular geometry where there are 4 bonds to a central atom. The name seesaw comes from the observation that it looks like a playground seesaw, so it moves like back and forth. Most commonly, 4 bonds to a central atom results in tetrahedral, or less commonly, square blend to 4 other atoms.